So we've gone and we've created our nice simple variable actor, the variable band, and it's time that we now create the drop targets that we're eventually going to align along this. So the drop target's rather simple to create, but the first element of this is we need to, as always, import the mesh. So I'm going to open up my files, and I'm just going to get sm_drop target and pop it into here. Import. So we've got our drop target. I know from the beginning that I want this to just be simple, white plastic. Doesn't have to be amazing. Save. So we've got ourselves the basic mesh. Let's go to blueprints. Let's right click and let's create ourselves a new blueprint class. And it's going to be an actor called BP_drop target. So the drop target is going to be relatively simple. It's going to have a couple of little things though that we need to really consider. Now, the first thing is we need to set ourselves up with a function that will drop the target and a function that will reset the target. So that's rather simple. First off, I'm going to add a component, which is going to be a static mesh. I'm not going to set it to be the root. It's just going to be sitting above the root, and it's going to be called DT mesh, which stands for drop target mesh. So I'm going to set that up as my drop target mesh, compile, save. And all I'm going to do here is I'm going to right click, create a custom event, and this is going to be called drop. After the drop event, I'm going to go custom event, and this is going to be called reset target. So I'm going to just take a shot in the dark with how I want these to function. I'm going to drag in DT mesh, and I'm going to drag off that and type move component, and I'm going to use the move component to function. And this is going to be rather straightforward. All we're going to do is when we want to drop it, we're going to say move. We're going to move component to -110 on the Z axis. I'm going to ignore X and Y for the time being because we just want it to go straight down. Next thing I'm going to do as a safety precaution is I'm going to set the collision enabled to be no collision. So I'm going to plug that in. Now next up we're going to have a play sound at location. So we'll play ourselves just a simple little sound effect every time it drops as well. So I'm going to right click, play sound at location, which is just going to be, the location is going to be the actor location. And the sound effect is going to be, for the time being, let's just play the bumper hit effect so we've got something. Eventually we'll switch that out to be its own unique thing. For reset target, it's going to be substantially more straightforward. I'm just going to set this to move to 0. So that's a completely standard thing, all set to 0. And finally, to get this functioning, I'm going to tell it that event hit. So when I get hit, I want to drop. Now, one of the things that we want to always check whenever we use hit is just make sure how our collision is set up. Now, in this case, we have block wall dynamic is checked, but we have one thing that is not, which is simulation generates hit events. So make sure you check that. Compile, save. So that's under collision if you can't see it. At this point, we now have a drop target that will theoretically drop and then, reset itself. But let's quickly test that. On begin play, I'm just going to add a delay. And after 1 second, it's going to drop. And then I'm going to add a delay again, which after 1 second is going to reset. So compile, save. And if I go to my viewport and I hit simulate, so now that we've told it to reset, and this is going up to XYZ on the 0, the next thing we need to do, that's very easy to mess up in this situation, is make sure that DT mesh is actually connected to your component here. If you're copying and pasting, it's very easy to leave that component reference empty. And of course, now that we're doing that, the other thing that we need to do is, in the same way over here that we set the collision to be no collision, I'm going to duplicate that, and I'm going to set the collision on this to now just say collision enabled again. So that should be a correct reset. So we're going to test that by setting a delay node off of begin play, which is going to have drop, delay, reset. So if I go to my viewport and I hit simulate, I can see after 1 second it goes down, and then after 1 second it goes back up. So we should be all good now for that to function. Now, with that working, I know that there are things that we're going to need to do later. I'm just going to make you aware of that now. At the moment, the target's not reporting anything to anyone to work out whether it's dropped or not. But that's okay. I'll show you how to do that in just a little bit. The thing that we need to set up though from here is our lettering, such that we have a character that is floating just in front of this. So I'm just going to add a component, and that component is going to be text render. Now by default, I'm going to get this text, and I'm going to set this text to say the letter U. So getting this text set up correctly just requires us to essentially kind of move this around until we've got something that really works. So I can see where the character is right now. I'm going to rotate this to be in 90 degrees on the Z axis. So it's now there. I'm also going to move it just a little bit in front. So 25 centimeters on the Y axis puts it there. I'm going to set the horizontal alignment to be equal to center. This way it's in the middle there. And now I'm just going to turn the size of it up to something that I think will work. So I'm going to try 5 and 5. Which looks okay. Yeah, 5 and 5 seem like good values for our X scale and Y scale. So that can be our basic character that sits there. Actually, I might move this just a bit closer because it's still pretty far out. At times like this, it's a good idea to disable the snap grid just to get it to the closest possible area you can. Cool, re-enable. The other thing that I think would be a good idea is that's a white character right now, but instead it might be a good idea to make it just a strong contrast. Now at the moment, if we were to run this, the U is actually not going to stay attached. This is going to drop down and the U is going to stay where it is. And that's because my text render component here isn't set to DT mesh. So this hasn't actually, I had to make sure that DT mesh was the parent of the actor that I was dropping in. Now finally, the other thing that I'm going to do here is I'm going to create a variable that is just going to be, it's going to be a string variable to keep things simple. And it's going to be called drop letter. So I'm going to expose this, and I'm also going to expose this on spawn, and I'm going to set the type to just be a string. Compile, save. And all this is going to be by default is a letter, so I'm going to put in F for the sake of testing. And in my construction script, I'm just going to get my drop letter. So when the construction script runs, it's going to get my text render component, and it's simply going to call on the text render set text. And the value that it's going to be looking for is just going to be drop letter. It's going to add an auto conversion because we're going from string type to text type, but that's okay, we can leave that. So now that we have that going, compile, save. If I hit my viewport, you can now see that whenever I change this variable to be something else, it's always going to equal that again, which is great. So now that we've got our drop target essentially created, the next thing that we need to do is create actor components in our new blueprint. So the variable band is in place, the drop target has been created. It's time for us to go about actually creating the final piece, which is to create an actor that we're going to call a drop target set. So I want you to right click on BP variable band and instead go create child blueprint class. Now I'm going to call this BP underscore drop target set. Okay? And you'll notice that when it's created, it looks identical to a standard variable band, but there's more to it. So how this is going to work is I'm essentially going to add actors to this actor according to the word that is specified as its variable, which means we need to go ahead and create ourselves a new variable that I'm just going to call drop target string. And I'm going to set this be a string variable. Compile, save. We're also going to make sure that this is public. And in my construction script, I'm now going to go ahead and create that functionality. Now I want to point out something. At the moment you can see that we have construction script and we also have parent construction script. This means that as long as this node is here, this node executes what its parent would normally run in its own construction script. Whereas everything beyond this point is going to allow me to expand upon that so that this actor has all of its functionality of its parent plus a little bit more. So in this case, what I'm going to do is, first off, I'm going to get my drop target string, and I'm actually going to run a quick little function on it called toUpper. Because anything that we have that we're putting in here, I want to make sure we're only using capital letters. So I'm going to now set the drop target string to be the capitalized version of the existing string. And now I'm going to drag off of that, and I'm going to type in a function called getCharacterArray from string. This is very useful because what it does is it breaks any string, so a line of text given into it here, into an array. Now I'm going to put in a test array at this point that'll just be a simple word. And what it's going to do is eventually this is now going to put out Udemy, and under getCharacterArray from string, this array is now going to have one letter in each single value of its array. So I'm going to drag off of that, and I'm going to do a for each loop. Now this for each loop is going to create a child actor component every time it iterates through. So what we're going to do is I'm going to drag off of the loop body, and for the time being I'm just going to add a child actor component. Now a child actor component means we're spawning a new actor that's parented to this as if it was a component of this actor. It's very useful functionality. I'm going to do drop target, and for the time being I'm going to tell it that it's relative transform. So we're just going to make this up as we go along as a quick test, but I'm going to go split, and I'm going to just for the time being tell it, just so you can see that they're all being added, that it's Z location, so this is going to go straight up, which is obviously not what we want in the long run, but I'm going to multiply the index, which is the current number in the array, multiplied by, let's say, 40 for testing. I'm going to plug that into here. This is set to drop target and this is set to there. So if I go view compile, you can now see that it's added letters going up again and again and again. So we know that it's adding these actors to our world. So this means that what we need to do is essentially we need to create something in our construction script that tells it where to place those actors. And if you think about the logic that we need to have there, let's have a look at it. We start here and we end here. We want to find the spaces in between and automatically place them. Now, we don't want to use the very ends. We want them to only be on the band. So a nice way for us to go about doing that is to, first off, we want to get the length of the distance between the two posts of our parent. So if I was to right click here and just, try to add a reference to post, I could, except how would I ever get my second post? So it's time for us to quickly expand something that we had in the variable band, and that is I'm going to go to here, and when we add the static mesh component for the second post, which is this one just here, I want you to right click and promote that to a variable that I'm just going to call post2. This means that at any stage if we want to modify post2 in the future, now we can. So I'm going to compile and save, and then go back to my drop target set. And this time when I right click here and I tap in post, you can now see that we have get post2, which means I can get a reference to both of these. So post 1, we want to get the relative location. Post 2, we want to get the relative location. At which point we want to subtract one from the other and then get the length, which tells us how far apart these are from each other. So this is a nice little function to quickly tell us how far apart these two things are. Now all I want to do from here is I want to figure out how spaced out the intervals should be given how far apart these are. So I'm going to use this and I'm going to divide it by the number of characters that we want to have. So to do that I'm going to get this, the length of this, and I'm actually going to add 1 to it so that it never fills up and adds an extra element to the end piece. So for the length plus 1, and what I'm going to do is, so I'm just going to clean this up as we go, reroute, and what I'm going to do is I'm going to divide by a float. I'm going to divide this by this. So the length divided by the number of pieces we want to have plus 1 so that we have a little bit of extra space on the end. At which point we now want to multiply that, because if I was to get this and just plug that, for instance, into X, well, the first issue that we have is we haven't gone ahead and told it where the gaps are. This tells us how far apart to place them, but we need this, there we go, to tell them where that specific element should be. Now this is not going to work when I plug it in, but you'll start to see what's going on. compile, you can now see that these are getting arranged in a straight line. And if I was to go and modify the value that we have for the location, so I'm going to delete this for the time being and instead put in a drop target set. If I was to add this and click on post location and stretch it out, you can see that it's expanding that space. However, it's still not correct. Now the reason it's not correct right now is we're offsetting by 1 on one end, but we need to offset it by 1 on the other end as well. So I'm going to go to my drop target set, and in my construction script, I'm going to add 1 to my array index. These pieces are now being correctly placed here. However, we have another issue. If I was to get my drop post and move it, it's sizing them along the x-axis, but it's not actually sizing them in a way that is between the 2 points. It's just going along its own local x. So how do we fix that? So we go to the drop target set, and what we do this time is after we've multiplied that by that, we now want to actually offset it so that it's facing down the direction of the post. So there's a great way to do that, which is if I get my post 1 and I find out which way forward is for that actor, I can now multiply this number. So keep in mind, at the moment, this is just a distance saying here's how far along you should be. And by multiplying that against a direction, that should be a multiplication against a vector. So multiplied vector by float. By multiplying these two against one another, I'm going to recombine this for a moment and plug this in. You're now going to see that if I get this, it's starting to actually place them in the correct location. So see, they're now actually stretching between the 2 locations. However, we have one final issue here, which is we need to make sure that the rotation is correctly set up as well. And that's okay, because the rotation just needs to be the rotation of this against, sorry, where is my drop target set construction script? It is the local rotation of the post 1. So I'm going to get relative rotation and connect this. And you'll see that these pieces are now correctly aligning themselves with the post, because we're already doing the rotation math. Now that that's out of the way, the only thing that we need to do from this point on is to actually add an offset so that these aren't just sitting in the middle. Now, if this is the forward vector along that direction, this would be considered the right vector. So all we need to actually do here is multiply the right vector by, say, 20 units and add that to our location. And what you'll see there is this. So we're getting the right vector at the moment and making that our location. Sorry, the forward vector, making that our location. But if we plus vector, so we're adding an offset, and this offset was simply equal to the post, we get the right vector. So that the right vector is a vector that points in the direction of the right of the object. By multiplying that against, say, 20, it's now going to be 20 units to the right. What does that mean? It means that it's now going to place those here. Save. Now at the moment, these are all being set to U, but they are being correctly placed now. So the final part for us to do in setting this up is to go back to our construction script, and after we add them, we now get this. Now, most people would expect this to return an actor reference, but it actually gives me a component reference, because remember, these are actually components in here. So what I need to do is drag off of that and type in child actor, and you'll see that we now have the ability to get access to the child actor. So with that, all I need to do is drag off of this, cast to drop target. So we're going to cast the actor to a drop target. And because it's a drop target, I'm now going to set the drop letter. And the drop letter is going to be equal to the current letter. So I'm going to get this and plug it straight in. Now there is still going to be an issue here, which is, well, you'll see in just a moment. If I go compile save, you can see that those are all still U's. Now the reason for that is that the function that we added in our drop target, which was to automatically set the letter in the construction script, this functionality doesn't actually work if we're doing it through a child actor. So we need to set that up a bit differently. So to do that, we go to the drop target set, construction script, and after we've set the letter to the correct letter, let's also just simply call set text on the text render that we've added. And I'm just going to make that equal to the letter that we set it to just then. So we're essentially replicating a construction script functionality here. If I look at this in the world, you can now see that this will automatically expand and contract where it can, and add the word that we've created, which is fantastic. So let's see how that actually works in a game. I'm going to add this word here, and I'm going to move the piece over to here, just so we have something that is theoretically easy to hit. And you can see that every time I hit them, they're now dropping. So going from here, the next thing that we need to do is to make sure that this actually knows how to handle itself from this point onwards. So it needs to know that when it drops, that we're actually assessing the number of things that have dropped and checking whether it's time to add a multiplier from this node yet. Which means it's time for us to start looking into some extended behaviors, which are going to be event dispatches. So we'll do that in the next lesson, but for the time being, write something cool, place it somewhere that's difficult to kind of reach, but still reachable, and expand your general play area.